September 19th, 1944, 7:30 hours. The morning fog rolls thick across the farmland near Arracourt, France, a small town in Lorraine that most soldiers cannot pronounce correctly. Staff Sergeant Lafayette Pool stands in the turret of his M4 Sherman, nicknamed In the Mood, scanning the gray wall of mist that obscures everything beyond 50 yards. The 25-year-old Texan from Odom feels the familiar weight of his tanker's helmet, hears the idle rumble of the Ford GAA engine behind him, smells the mixture of gun oil and spent cordite that never quite leaves a combat vehicle. He has been in action for 81 days straight, and his crew has destroyed 11 enemy tanks. Today they will face their greatest test. 3 miles east, Hauptmann Franz Beck briefs his company commanders from the 113th Panzer Brigade. His men sit in brand-new Panther tanks, each mounting the feared 75 mkWk 42L70 gun, capable of penetrating 138 millimeters of armor at 1,000 meters. The Panther weighs 45 tons, sports sloped frontal armor up to 80 millimeters thick, and can reach speeds of 34 miles per hour. Beck's intelligence reports indicate the Americans ahead are equipped with M4 Shermans, the medium tank that German crews have learned to mock. The Sherman weighs only 33 tons. Its 75 mm3 gun can barely scratch a Panther's frontal armor beyond 500 meters, and its flat armor plates seem designed to catch and hold every German shell. One of Beck's gunners laughs as he chalks another tally mark on his gun barrel, joking that American tankers drive their own coffins into battle. The Germans call them Tommy Cookers when fighting the British, referencing how quickly they burn when hit. Some younger crews have heard rumors of a nickname, Ronson, after the cigarette lighter, though this name exists more in bitter humor than official designation. Beck's men expect this to be another easy victory, another day of hunting the inferior American armor that seems to exist only to pad their kill counts. The fog saves Pool's life in the opening minutes. The German attack emerges from the mist like steel ghosts, 4 companies of Panthers supported by assault guns and 2 battalions of Panzer Grenadiers. The lead German tank, advancing blind through the thick autumn fog, exposes its thinner side armor as it searches for targets. Pool's gunner, Corporal Willis Aller, acquires the silhouette through his periscope sight. Pool's voice cuts through the intercom, calm and precise despite the adrenaline spiking through his system. Range 800 yards, target left, traverse left. Aller's foot presses the firing pedal. The 75 gun roars, the entire Sherman rocks backward from the recoil, and the armor-piercing round streaks across the morning air at 2,030 feet per second. It punches through the Panther's side armor, detonating the ammunition stored in the hull. The German tank explodes in a geyser of flame and smoke. First kill of the day. Pool's loader, already moving with the automatic precision of a crew that has fought together for months, rams another round home. The breech slams shut. Ready. Pool scans for the next target. This is what Sherman crews learn to do. They learn to survive. What the Germans at Arracourt do not understand, what Hauptmann Beck will learn over the next 11 days as his brigade is systematically destroyed, is that they are not fighting individual tanks. They are fighting a system, an industrial philosophy, a tactical doctrine that transforms perceived weakness into strategic dominance. The M4 Sherman, derided as a death trap, mocked as a lighter on wheels, dismissed as inferior by every metric that matters in tank versus tank combat, wins the war. Not through superior armor, not through a bigger gun, not through individual technical excellence. The Sherman wins through something the Germans, with their focus on engineering perfection and tactical supremacy, fail to comprehend until far too late. The Sherman wins through overwhelming numbers, mechanical reliability, crew survivability, rapid replacement, combined arms integration, and a tactical doctrine that refuses to fight the enemy's battle. The story of how America's most produced tank transformed from object of ridicule to instrument of victory begins not on the battlefields of Europe, but in the design rooms and factories of the United States, where engineers faced a problem that would define modern warfare. How do you build a tank that can win a global war? The German answer was to build the best tank possible, regardless of production complexity or logistical burden. The American answer was to build a tank that was good enough, reliable enough, and producible in such quantities that battlefield losses became mathematically irrelevant. The Germans built the Tiger I, a masterpiece of engineering with an 88mm gun that could destroy any Allied tank at ranges exceeding 2,000 meters, frontal armor up to 100 millimeters thick, and a reputation that preceded it onto every battlefield. Between August 1942 and August 1944, German factories produced 1,347 Tiger I tanks. In that same period, American factories produced more than 40,000 Shermans. The United States built 30 Tigers worth of Shermans every single month for 3 years straight. This was not an accident. This was the strategy. The M4 Sherman emerged from the M3 medium tank program, which itself represented a compromise born of pre-war limitations. American tank doctrine in the late 1930s reflected two competing philosophies. The infantry wanted a heavily armored support vehicle to accompany foot soldiers, while the cavalry wanted a fast, mobile tank for exploitation and reconnaissance. The M3, with its 75mm gun mounted in a hull sponson and a 37mm gun in the turret, satisfied neither branch completely, but represented the best American designers could achieve with existing technology and limited experience. The M3 proved its worth in North Africa, where British forces used it to help halt Rommel's advance, but everyone recognized its limitations. A hull-mounted main gun meant limited traverse, making the tank vulnerable in close combat and urban fighting. The solution emerged in early 1941, when designers successfully mounted the 75mm gun in a fully rotating turret, creating the M4. The design philosophy behind the Sherman prioritized factors that paper specifications and firing range tests cannot measure. Reliability stood first. The Sherman used the Continental R975 radial aircraft engine in early models, later switching to the Ford GAA V8, the Chrysler A57 multibank, and General Motors 6046 twin diesel, depending on variant and availability. This variety of power plants, which might seem like a logistical nightmare, actually demonstrated American industrial flexibility. Each engine delivered reliable performance, and more importantly, each could be produced in quantity without bottlenecking tank production. The transmission used automotive technology rather than the complex, temperamental designs favored by German manufacturers. German tankers often joke that their Tigers and Panthers spend more time in repair shops than in combat, and this is not entirely humor. The Tiger I, for all its fearsome reputation, suffers from a transmission system so delicate that simply turning the tank in place risks throwing a track. The final drive units fail regularly, especially in the brutal conditions of the Eastern Front. Panthers experience engine fires with alarming frequency. A study of German armored operations reveals that mechanical reliability rates hover around 60% for heavy tanks, meaning that at any given time, 40% of Germany's most powerful armor sits immobile, waiting for parts that increasingly scarce supply lines cannot deliver. The Sherman, by contrast, achieves mechanical availability rates approaching 96%. This figure deserves emphasis because it represents the difference between a tank that fights and a tank that watches. When an American armored division advances, nearly every tank in the formation can move and shoot. When a German Panzer division attacks, a significant portion of its strength already sits on the roadside, victims of mechanical failure rather than enemy action. The Sherman's automotive-grade components mean that repairs can be completed in the field using standard tools and readily available parts. A Sherman with a damaged engine can have the entire power plant replaced in 4 hours by a maintenance crew. A Tiger with a broken transmission might wait weeks for a replacement unit that must be shipped from Germany, assuming the factories can produce it amidst Allied bombing campaigns that increasingly target industrial infrastructure. This reliability multiplies the effective strength of every Sherman unit. A division with 200 Shermans can field 192 operational tanks on any given day. A Panzer division with 100 Tigers might field 60. The mathematics of attrition warfare favor the side that can keep its equipment running. Production capacity represented another deliberate design choice. The Sherman measured 19 feet 4 inches long, 8 feet 7 inches wide, and 9 feet tall, dimensions carefully calculated to fit inside standard railroad tunnels and across existing bridges in both Europe and the Pacific. Weight remained under 35 tons, light enough for most engineering equipment to transport and position. The vertical volute spring suspension system used simple, robust components that could be manufactured by automotive suppliers across America. The turret design allowed multiple gun configurations without requiring complete redesign of the entire tank. This modularity proved crucial as the war progressed and armament needs changed. Early Shermans mounted the 75 mm3 gun, excellent for high-explosive work against infantry and fortifications, but increasingly inadequate against improved German armor. American designers responded by developing the 76 mm1A1 gun, which could penetrate significantly more armor at combat ranges. The Sherman's turret ring, at 69 inches, provided enough space to accommodate this larger weapon without requiring a new tank design. British engineers took this further, managing to fit their powerful 17-pounder anti-tank gun into a modified Sherman turret, creating the Sherman Firefly. This adaptability meant that production lines could continue building proven, reliable tanks, while armament improved to meet changing battlefield requirements. The sheer scale of Sherman production demonstrates American industrial capacity at its peak. 11 major manufacturers produced Sherman variants between 1942 and 1945. The Press Steel Car Company, Baldwin Locomotive Works, American Locomotive Company, Pullman Standard Car Company, Detroit Tank Arsenal, Lima Locomotive Works, Pacific Car and Foundry Company, Fisher Tank Arsenal at Grand Blanc, Ford Motor Company, and Federal Machine and Welder Company all contributed to production. These facilities produced Shermans at a combined rate that peaked at over 2,000 tanks per month in 1943. The Detroit Tank Arsenal, a purpose-built facility constructed in 1940, could produce one complete M4A3 Sherman every 2 hours at maximum production tempo. Workers assembled tanks on a production line similar to automobile manufacturing, with each station completing specific tasks before the hull moved to the next position. This assembly line approach, revolutionary in tank production, reduced costs and construction time while maintaining quality control. A Tiger I required approximately 300,000 man-hours to produce. A Sherman required approximately 7,500 man-hours. Germany could build one Tiger in the time America built 40 Shermans. This economic reality determined the war's outcome more certainly than any individual tank versus tank engagement. But production numbers alone do not explain the Sherman's success. Dead crewmen cannot benefit from replacement tanks, no matter how quickly factories produce them. The Sherman's greatest advantage, the factor that German crews consistently underestimate until they face it repeatedly, is crew survivability. Early war Shermans suffer from a well-documented problem: ammunition fires. The tank carries up to 90 rounds of 75 ammunition, each containing over 2 kilograms of propellant designed to burn quickly and completely. In early models, ammunition racks lined the interior hull walls, unprotected except by the hull armor itself. When an enemy shell penetrates this armor, it frequently strikes stored ammunition, igniting the propellant. One round ignites, then then the entire ammunition load burns in a cascading fire that turns the tank's interior into a crematorium. Burn rates for penetrated early-model Shermans reach as high as 80%, a horrific statistic that gives birth to the dark humor and bitter nicknames. British crews call their Shermans Ronsons, after the lighter brand, though this nickname appears more in post-war accounts than contemporary documents. German crews call them Tommy Cookers, and the name sticks because it reflects an observable reality on too many battlefields. The critical difference between the Sherman and German tanks is not that the Sherman burns when penetrated. Every tank of World War II burns when penetrated under the right circumstances. The difference is that American engineers identify the problem, develop solutions, and implement them in production and as retrofits to existing tanks. The first solution, called the Quick Fix, adds applique armor panels to the hull sides, providing extra protection over ammunition storage areas. More importantly, it relocates 12 rounds from exposed racks in the turret bustle to protected storage. This modification reduces burn rates but does not eliminate the problem. The complete solution, implemented in Sherman production beginning in late 1943, is wet stowage. Engineers redesigned the ammunition racks as sealed containers surrounded by liquid-filled jackets. Water and glycol mixture fills these jackets. When a shell penetrates near ammunition storage, the liquid absorbs heat and, if ruptured, floods the immediate area, suppressing fire before it can spread to other rounds. Wet stowage reduces the burn rate to approximately 15%, a dramatic improvement that transforms the Sherman from a potential death trap into one of the safest tanks on the battlefield. Crew positions and escape hatches further enhance survivability. The Sherman provides 5 crew positions: driver and bow gunner in the hull, commander, gunner, and loader in the turret. Each position has at least one escape route and most have multiple options. The driver can exit through an overhead hatch or through the bow gunner's position. The bow gunner has his own overhead hatch. All 3 turret crew have access to the commander's cupola hatch, the loader's hatch, and an emergent escape hatch in the turret floor. These hatches use spring-loaded mechanisms that can be operated quickly even under combat stress. German tanks, particularly the later Panther and Tiger II, have fewer and smaller hatches, making emergency egress more difficult. A study of tank crew casualties shows that American tank crewmen have approximately a 50% chance of surviving a tank being knocked out, accounting for both tanks destroyed in combat and tanks abandoned due to mechanical failure or tactical necessity. This survival rate, substantially higher than rates for German tank crews, means that experienced Sherman crews remain in the war, learning from each engagement, improving their tactics, and training replacements with hard-won knowledge. German Panzer aces, regardless of their individual skill, represent irreplaceable assets. When they die, their expertise dies with them. American tank crews represent renewable resources. Lafayette Pool, shot through the leg by a German sniper on September 19, 1944, returns to service after rehabilitation and serves as an instructor, passing his knowledge to hundreds of new tankers. The American replacement and training system, often criticized for its impersonal nature, and the practice of feeding individual replacements into units rather than keeping training groups together, nonetheless keeps armored divisions at fighting strength throughout the war. Training programs at Fort Knox, Kentucky, and other facilities process thousands of tankers through progressive courses that begin with basic military training and culminate in unit-level tactical exercises. The training emphasizes mechanical maintenance, believing correctly that a crew that understands how their tank functions can keep it operational under field conditions. Gunnery training stresses rapid target acquisition and engagement over long-range precision, reflecting the tactical reality that Sherman crews must close to effective range and fire first to survive against superior German armor. Most importantly, training instills crew cohesion. A tank crew fights as a single organism, each member performing assigned duties while maintaining awareness of the overall tactical situation. The commander controls the battle, selecting targets and directing the driver. The gunner engages targets as directed, making minor adjustments for range and movement. The loader maintains ammunition supply, selecting the appropriate round type for each target. The driver maneuvers the tank according to the commander's instructions while watching for obstacles and threats. The bow gunner operates the .30 caliber machine gun against infantry threats, while serving as a second set of eyes for the driver. This division of labor, practiced until it becomes instinctive, allows Sherman crews to operate effectively in the confusion and terror of combat. December 14, 1944, near the village of Bastogne, Belgium. Technical Sergeant John Roller commands a Sherman from Company C, 10th Tank Battalion, 4th Armored Division. His crew has been in combat for 6 months, fighting from the hedgerows of Normandy through the breakout at Cobra, across France, and now into the Ardennes forest in Belgium. The temperature hovers just above freezing, and thick clouds promise snow. Roller's Sherman, designated C7, has 243 operational hours on the current engine, a Ford GAA V8 that purrs with mechanical satisfaction. The tank has been hit 3 times in its combat career, once in Normandy by an 88 Michel that penetrated the lower hull and killed the bow gunner, once outside Metz by a Panzerfaust that damaged the left track, and once by a Panther that struck the upper glacis at an oblique angle and miraculously failed to penetrate. Each time, the tank returned to action within days. The bow gunner was replaced by a kid from Ohio who arrived as an individual replacement and integrated into the crew within a week. The track was replaced in 6 hours. The glacis hit required no repair beyond cleaning the gouge and repainting the affected area. Roller's company is moving to relieve the 101st Airborne Division, trapped in Bastogne by the German counteroffensive that history will call the Battle of the Bulge. Intelligence reports indicate that German forces include elements of the 2nd Panzer Division, equipped with Panthers and Panzer IVs, possibly supported by a company of Tigers. Roller has engaged Panthers twice before. The first time, his gunner's initial shot bounced off the Panther's frontal armor from 600 yards, and only a flanking shot from another Sherman destroyed the German tank before it could return fire. The second time, Roller's crew engaged a Panther from ambush at 150 yards, firing 4 rounds into its side armor in rapid succession. The Panther burned. Roller understands the Sherman's limitations against German heavy armor, and he understands the tactics that overcome those limitations. Never attack a Panther or Tiger from the front. If any alternative exists, use terrain to close the range and maneuver for flank shots. Work with other tanks to present multiple threats simultaneously, forcing the German commander to choose which threat to engage. Use high explosive rounds to damage vision ports, tracks, and external equipment, immobilizing the enemy tank and allowing friendly forces to maneuver for kill shots. Most importantly, never fight alone. The Sherman is part of a combined arms team, and trying to engage German armor without infantry support, artillery coordination, and air cover is suicide. The relief of Bastogne demonstrates these principles in action. The 4th Armored Division's advance on the besieged town involves 3 task forces: Task Force Odin approaching from the southwest, Task Force Churchill from the south, and Task Force Baum from the southeast. Each task force integrates tanks, armored infantry, artillery, engineers, and tank destroyers into a balanced combat team. Air support from the XIX Tactical Air Command flies constant missions when weather permits, attacking German positions and supply columns. The P-47 Thunderbolts, carrying bombs and rockets, prove particularly effective against German armor, forcing panzer crews to remain under cover or risk destruction from above. This air threat restricts German movement to dawn, dusk, and periods of poor weather, limiting their ability to concentrate forces for counterattacks. When German armor does appear, American tactics call for Shermans to suppress and fix the enemy position while tank destroyers, with their more powerful guns, maneuver for kill shots. The M10 and M36 tank destroyers mount 3-inch and 9-inch guns respectively, weapons capable of penetrating Panther and Tiger armor at reasonable combat ranges. This division of labor plays to each vehicle's strengths. Shermans provide mobile firepower for general combat operations. Tank destroyers handle enemy armor. January 3, 1945, in the town of Singeling, France, near the German border. First Lieutenant William A. Hamburg commands a Sherman from a company, 35th Tank Battalion. His crew encounters a German Tiger tank dug into a defensive position, with only its turret exposed. The Tiger spots Hamburg's Sherman first and fires. The 88 armor-piercing round strikes the Sherman's front slope, penetrates the armor, and continues through the fighting compartment, exiting through the rear plate. The hydraulic fluid sprays across the interior, the intercom system fails, and the smell of burning insulation fills the air. Hamburg, standing in the turret hatch as was his habit in combat, is thrown backward by the impact but not injured. His gunner, loader, and bow gunner bail out through their respective hatches in seconds. The driver, momentarily trapped when debris blocks his hatch, forces it open and exits. The entire crew survives. The Sherman, remarkably, does not burn despite the penetrating hit, the wet stowage system having prevented an ammunition fire. Within 6 hours, a recovery vehicle tows the damaged Sherman to a rear area maintenance facility. Within 3 days, mechanics replace the damaged components using parts from the extensive supply system. Within 5 days, the tank returns to action with the same crew. The Tiger that destroyed Hamburg's Sherman survives this engagement, but is abandoned 2 days later when it suffers a transmission failure during a retreat and cannot be recovered. German engineers disable it with demolition charges to prevent capture. This pattern repeats across every front where Shermans engage German armor. Individual engagements often favor the Germans, their superior guns and armor allowing them to destroy Shermans at ranges where the American tanks cannot effectively return fire. But individual engagements do not win wars. Campaigns win wars. Strategic objectives win wars. And in the mathematics of campaign-level combat, the Sherman's advantages accumulate into decisive superiority. For every Sherman destroyed, 2 more arrive from replacement depots. For every Sherman crew killed, replacements trained at facilities in the United States fill the positions. For every tank engagement lost, American forces adapt their tactics, improving their performance in subsequent encounters. German forces lack this resilience. Panthers and Tigers destroyed in combat cannot be replaced quickly. Production cannot keep pace with losses. German crews, increasingly composed of young men with minimal training as experienced tankers die or become prisoners, cannot match the improving skill level of American tankers. German fuel supplies, targeted by Allied strategic bombing and increasingly cut off by partisan activity and ground advances, limit training and tactical movement. By late 1944, the German army frequently abandons perfectly functional tanks because it lacks the fuel to operate them or the recovery vehicles to retrieve them when they break down. Otto Carius, the German Panzer ace credit. With destroying more than 150 enemy tanks during his service on the Eastern and Western fronts, writes extensively about his experiences in his post-war memoir, Tigers in the Mud. Carius earns the Knight's Cross with oak leaves, commands Tiger and Jagdtiger units, and survives the war to provide one of the most detailed accounts of German armor operations. His testimony regarding American armor proves illuminating precisely because he respects his opponents even as he catalogs German technical superiority. Carius writes about a fundamental problem that German panzer forces face in the West. The Americans never came at us in ones or twos. They came in groups of 5, 10, sometimes 20 tanks, supported by infantry and artillery, with aircraft circling overhead. You could destroy 3, 4, even 5 of their tanks and the rest would keep coming. Our guns were better. Our armor was thicker. But we were always outnumbered, always fighting on ground of their choosing, always watching the sky for their aircraft. This testimony captures the essential reality of Sherman operations. American tactical doctrine, refined through combat experience from North Africa through Sicily, Italy, and into Northwest Europe, emphasizes combined arms coordination and numerical superiority at the point of contact. American commanders understand that individual Shermans cannot match German heavy armor in direct combat, so they ensure that individual Shermans never fight alone. The Battle of Arracourt, where Lafayette Pool's crew fights that foggy September morning in 1944, becomes a textbook example of Sherman tactics defeating superior German armor. The 4th Armored Division's Combat Command A, equipped primarily with M4A1 and M4A3 Shermans mounting 75 guns, faces the German 5th Panzer Army's 113th Panzer Brigade and elements of the 11th Panzer Division. German forces field approximately 262 tanks and assault guns, including 100 Panther tanks fresh from German factories. The Panthers represent Germany's answer to Soviet T-34s encountered on the Eastern Front. Sloped armor, powerful gun, and reasonable mobility in a single package. On paper, a Panther should dominate a Sherman. In practice, over 11 days of fighting, Combat Command A destroys or forces the abandonment of 281 German armored vehicles while losing 48 Shermans. The exchange ratio approaches 6-to-1 in favor of the Americans, the exact opposite of what German tank specifications suggest should occur. Several factors explain this outcome. First, intelligence. American forces have comprehensive information about German positions, strength, and intentions, gathered through aerial reconnaissance, radio intercepts, and prisoner interrogation. German forces, lacking effective reconnaissance units and operating with increasingly degraded intelligence networks, advance essentially blind into American positions. Second, terrain. Combat Command A fights from carefully selected defensive positions that negate German range advantages and allow American tanks to engage at distances where their 75 guns remain effective. Third, tactics. American commanders position Shermans in groups, ensuring that German tanks face multiple threats simultaneously. When a Panther engages one Sherman, others maneuver for flank shots. Fourth, coordination. American operations integrate armor with infantry, artillery, and air support. When German tanks attack, they face not just tank guns but artillery barrages that disrupt formations and air attacks that destroy vehicles and kill crews. Fifth, persistence. American forces use their numerical superiority to maintain continuous pressure. German forces, unable to replace losses or repair damaged vehicles quickly, steadily weaken with each engagement. By the end of the battle, the 113th Panzer Brigade effectively ceases to exist as a combat formation. The air component deserves particular emphasis because it represents a Sherman advantage that tank specifications cannot measure. The XIX Tactical Air Command, supporting ground operations in Lorraine, flies hundreds of sorties during the Arracourt battle. P-47 Thunderbolts, carrying 8 rockets or 2,500 pounds of bombs, hunt German armor relentlessly. The P-47's radial engine makes it durable and reliable, able to sustain battle damage and return to base. Its 8.50 caliber machine guns can destroy soft-skinned vehicles and suppress German infantry. Its ordnance load can destroy or disable any German tank with a direct hit. Most importantly, P-47s can arrive over the battlefield within minutes of being called by forward air controllers operating with ground units. German panzer commanders learned to fear the sound of American aircraft, knowing that movement during daylight hours brings near-certain death. This air superiority forces German forces to move at night or in poor weather, limiting their operational flexibility and making it impossible to concentrate forces for effective coup. In terror-attacks, Otto Carius notes this factor repeatedly in his memoir, writing that the Americans owned the sky, and we owned only the ground our tanks currently occupied. June 6, 1944, Omaha Beach, Normandy. The first Shermans weighed ashore as part of the D-Day landings, specifically the DD duplex drive variants equipped with flotation screens that allow them to swim through shallow water. Many sink in the rough seas, their crews drowning as the tanks disappear beneath the waves. Those that reach the beach provide crucial fire support for infantry pinned down by German defensive positions. The 741st Tank Battalion loses 27 of 32 DD Shermans during the landing, but the 5 that reach the beach help break the German resistance at the WN-62 strongpoint, allowing infantry to advance off the beach. The 743rd Tank Battalion lands its Shermans directly on the beach using landing craft, suffering fewer losses and providing more immediate support. The ability to bring armor ashore during the critical early hours of the landing proves decisive in establishing and holding the beachhead. German defenders, expecting to face unprotected infantry, find themselves engaging tanks whose 75 guns can destroy bunkers and whose armor can withstand small arms and machine gun fire. The psychological impact of armor arriving with the first assault waves disrupts German defensive plans and prevents effective counterattacks during the vulnerable period when Allied forces consolidate their positions. The subsequent fighting in Normandy's Bocage country tests Sherman crews and American tactics more severely than any previous campaign. The bocage consists of agricultural land divided into small fields by earth embankments topped with thick hedgerows, creating a maze of natural fortifications. Each field becomes a potential ambush site. German defenders, equipped with Panzerfaust anti-tank rockets, Panzerschreck anti-tank weapons, and positioned anti-tank guns, turn the bocage into a nightmare for Allied armor. Shermans attempting to cross hedgerow embankments expose their thin belly armor as they climb, making them vulnerable to even light anti-tank weapons. The hedgerows themselves limit visibility to a few hundred feet, negating American advantages in air support and artillery, while playing to German strengths in defensive combat. Initial advances proceed slowly and at high cost. American tank crews, accustomed to fighting in open terrain where they can maneuver and use their numbers effectively, find themselves channeled into killing zones where German defenders can engage individual tanks before reinforcements arrive. American ingenuity provides the solution. Sergeant Curtis G. Cullen, Jr., a tanker from the 102nd Cavalry Reconnaissance Squadron, observes that hedgerow embankments stop Shermans not because of their height, but because the embankments are so densely packed that tanks cannot push through them. Cullen designs a hedgerow cutter using steel salvaged from German beach obstacles, creating a fork-like device that mounts on the Sherman's front. When driven into a hedgerow, the cutter's prongs dig into the embankment, allowing the Sherman to bull through rather than climb over. The innovation, dubbed the Rhino or Cullen cutter, spreads rapidly through American armored units. Ordnance companies manufacture thousands of cutters from salvaged steel, and within weeks, most Shermans in Normandy mount some version of the device. This simple modification transforms the tactical situation. Shermans can now advance through hedgerows unpredictably, appearing in locations German defenders do not anticipate, attacking from unexpected directions, and using the hedgerows for cover rather than being trapped by them. Combined with improved infantry-tank coordination, where infantry scouts ahead to locate German positions and tanks provide fire support before advancing, American forces develop effective bocage tactics. The learning curve is steep and the casualties high, but American forces adapt while German forces, unable to replace losses or redeploy units from other fronts, steadily weaken. July 25, 1944, Operation Cobra begins. This massive offensive, designed to break through German defenses south of Saint-Lô and enable American forces to break out of Normandy, opens with the most concentrated aerial bombardment in support of ground forces attempted to that date. Over 1,500 heavy bombers, 380 medium bombers, and 550 fighter bombers drop approximately 4,000 tons of ordnance on German positions in a target area measuring 5 miles by 1 mile. The bombardment devastates German defenses, destroying equipment, killing personnel, and leaving survivors shocked and disoriented. Sherman-equipped armored divisions exploit the breach, advancing through the shattered German lines and into the French interior. The lead elements cover 60 miles in the first 3 days, a pace that German forces cannot match or count. The breakout validates American doctrine. Use overwhelming firepower to create a breach, then exploit with mobile armored forces that bypass German strongpoints and drive deep into the enemy rear area, disrupting communications, destroying supply dumps, and forcing German units to retreat or be encircled. The pursuit across France sees Sherman-equipped units operating at the limits of their logistical tether. Fuel consumption becomes the limiting factor, not German resistance. The 4th Armored Division, spearheading 3rd Army's advance, frequently pauses not because of enemy action, but because supply trucks cannot keep pace with the armored advance. This operational tempo, impossible for German forces to maintain given their logistical situation, demonstrates another Sherman advantage. Operational reliability allows American forces to maintain sustained offensive operations. Panthers and Tigers, when running, can match or exceed Sherman performance in individual engagements, but they cannot maintain the operational tempo because they break down too frequently and consume too much fuel. A Tiger I averages 0.67 miles per gallon of gasoline. A Sherman averages 1.9 miles per gallon. This 3-to-1 difference in fuel efficiency means that Shermans can operate 3 times as far from supply depots, or that supply trucks can support 3 times as many Shermans as Tigers over equivalent distances. In a war where logistics determines operational possibilities, the Sherman's efficiency proves as valuable as any weapon system. Lieutenant Colonel Creighton Abrams, commander of the 37th Tank Battalion, 4th Armored Division, personifies aggressive Sherman employment. Abrams, who will later rise to command all U.S. forces in Vietnam and serve as Army Chief of Staff, leads his battalion from the front, personally commanding the lead tank during critical phases of combat. His battalion motto, "Courage is fear holding on a minute longer," reflects the tactical reality of Sherman combat. Individual tank versus tank engagements favor the Germans, but American crews who maintain discipline, continue fighting despite losses, and trust in their numerical superiority and combined arms support ultimately prevail. Abrams develops tactics for urban combat, where the close range negates German armor advantages and allows Sherman crews to engage with high-explosive ammunition and machine gun fire. His battalion fights through numerous French towns, systematically clearing German defenders using coordinated infantry tank teams. The tanks provide mobile fire support, destroying buildings that house German positions, while infantry advances under this cover to clear structures and locate hidden anti-tank weapons. These urban tactics prove so effective that they become doctrine, taught at training facilities and disseminated throughout armored units. The performance of Sherman variants deserves examination because American willingness to modify and improve the basic design provides additional advantages. The M4A3E8, called the Easy 8 by crews, incorporates numerous improvements based on combat experience. It mounts the 76 M1A1 gun, providing better anti-armor capability than the original 75 weapon. It uses the horizontal volute spring suspension, HVSS, which provides better weight distribution, improved cross-country performance, and allows the mounting of wider tracks that reduce ground pressure. The wider tracks, measuring 23 inches instead of the original 16.5 inches, dramatically improve mobility in soft ground and snow. The EZ-8 also benefits from wet ammunition storage as standard equipment, enhanced vision blocks for the commander, and improved ballistic protection. These modifications transform the Sherman into a tank that can engage Panther tanks under favorable conditions and expect a reasonable chance of success. The EZ-8, entering service in quantity in late 1944, provides American armored forces with equipment better matched to the tactical situation in Germany, where combat increasingly involves assault against prepared defensive positions rather than mobile warfare in open terrain. The British Sherman Firefly deserves special mention as perhaps the most effective Allied tank of the war, combining the Sherman's reliability with armament capable of defeating any German tank. British engineers, recognizing that existing British tank designs could not accommodate the powerful 17-pounder anti-tank gun within reasonable time frames, undertook the challenging task of fitting this weapon into the Sherman turret. The 17-pounder fired a 17-pound projectile at 2,900 feet per second, generating sufficient kinetic energy to penetrate Tiger and Panther frontal armor at combat ranges. The gun's size created significant challenges. The recoil mechanism had to be rotated 90 degrees, placing it behind the gunner rather than below the gun. The radio had to be relocated from the turret bustle to the hull. The odor's position became cramped, and the rate of fire suffered compared to standard Shermans. Despite these compromises, the Firefly proved devastatingly effective in combat. British armored units typically operated with one Firefly per troop of 4 tanks, a ratio that provided sufficient anti-armor capability while maintaining the numerical advantage of standard Shermans for general combat duties. German tank commanders learned to identify and prioritize Firefly targets, recognizing that the longer-barreled Firefly posed the most significant threat. British crews responded by painting fake muzzle brakes on standard Shermans and attempting to disguise Firefly barrels, though these efforts met with limited success given the distinctive barrel length. The Firefly's effectiveness is documented in numerous after-action reports and crew testimonies. In the fighting around Caen in June and July 1944, Fireflies accounted for a disproportionate share of German tank kills, frequently engaging and destroying Tigers and Panthers at ranges exceeding 1,000 yards. The United States offered the opportunity to produce Fireflies or adopt the 17-pounder gun, declined, preferring to proceed with the 76mm gun for Shermans and the 90mm gun for tank destroyers and the new M26 Pershing heavy tank. This decision, controversial both at the time and in historical analysis, reflected American confidence in existing equipment and reluctance to complicate logistics by introducing a non-standard gun requiring unique ammunition. Whether this decision cost American lives remains debated, but the Firefly's combat record demonstrates that the basic Sherman design could accommodate weapons sufficient to engage the heaviest German armor on equal terms. August 8, 1944, the village of Sintho, south of Caen. Michael Wittmann, Germany's most famous tank ace, leads a group of Tigers from the 101st SS Heavy Panzer Battalion into combat during Operation Totalize, a Canadian-led offensive. Wittmann, credited with 138 tank kills, embodies German Panzer tradition, aggressive, skilled, and absolutely confident in his equipment's superiority. His Tiger advances to engage Canadian and Polish armored forces pushing south. What happens next remains disputed, with various accounts attributing Wittmann's death to different Allied units. What is undisputed is that Wittmann's Tiger explodes, killing him and his entire crew. British, Canadian, and Polish units all claim the kill. The most likely scenario, based on tactical analysis, is that a Sherman Firefly from the Northamptonshire Yeomanry, commanded by Sergeant Gordon, engages Wittmann's Tiger from a flanking position, firing a 17-pounder armor-piercing shot that penetrates the Tiger's side armor and detonates the ammunition. The Tiger's turret is blown completely off the hull by the internal explosion. Whitman's death demonstrates a fundamental truth that German panzer forces learn repeatedly throughout 1944 and 1945. Individual skill and superior equipment cannot overcome numerical disadvantage and tactical coordination. Whitman, perhaps the most skilled tank commander in the German army, dies in an engagement where Allied forces bring overwhelming numbers to bear, coordinate movement to attack from multiple directions, and ensure that even the most capable German crews face impossible tactical situations. The myth of the invincible Panzer ace, cultivated by German propaganda and sustained by impressive individual kill counts, crumbles against the reality of Allied material superiority. Every German tank ace, regardless of skill, eventually faces a battle where numbers, firepower, and tactics favor the Allies. Some aces survive these battles by retreating, by being transferred to training duties, or simply by luck. Many do not. The irreplaceable expertise dies with them. The contrast with American tank ace Lafayette Pool is instructive. Pool, as noted, achieves his kills over 81 days of continuous combat from June 27 to September 19, 1944. He operates in a military system that understands tank commanders are valuable but not irreplaceable. When Pool loses a leg to a mine, the U.S. Army does not attempt to return him to combat despite his obvious skill and proven record. Instead, Pool becomes an instructor, training new tank commanders and passing his tactical knowledge to hundreds of students. This approach, multiplying expertise rather than concentrating it in individuals, proves far more effective at the strategic level. Germany produces a dozen extraordinary tank aces. America produces thousands of competent tank commanders. War rewards the latter approach. The Philippines, 1945. The 44th Tank Battalion, equipped with M4A3 Shermans, supports the 6th Infantry Division during the liberation of Luzon. The terrain, mountainous jungle with few roads and limited visibility, represents the worst possible environment for armored operations. Yet the Shermans prove invaluable. Their 75 guns destroy. Why Japanese bunkers and pillboxes that infantry cannot reduce with available weapons? Their armor protects crews from small arms fire and grenades, allowing them to provide close support in situations where unprotected vehicles would be destroyed immediately. Their reliability means they remain operational despite tropical heat, humidity, and rough terrain that defeats less robust equipment. In the battle for Manila, Shermans advanced through urban streets, providing fire support for infantry clearing Japanese defenders from buildings. The coordination between tanks and infantry becomes so refined that tank commanders develop hand signals allowing infantrymen to direct fire onto specific targets without using radio communications. This intimate cooperation, practiced and perfected through months of combat, represents the ultimate development of combined arms tactics. The Sherman, designed as a medium tank for general combat duties, proves adaptable enough to function effectively in every environment from North African deserts to Pacific jungles, from French farmland to German cities. The Soviet Union receives approximately 4,000 Shermans through Lend-Lease, primarily M4A2 variants with diesel engines preferred by Soviet logistics. Soviet crews, experienced in operating the T-34, compare the two tanks extensively. Soviet after-action reports note that the Sherman provides superior vision for the commander through multiple periscopes and a cupola, better ergonomics for the crew with more internal space, and significantly better reliability. The T-34, while possessing better armor and comparable firepower, suffers from cramped crew conditions, poor vision blocks, and mechanical reliability issues. Soviet tanker Dmitry Loza, who commands a battalion equipped with Shermans, writes in his memoir that his men prefer the Sherman once they overcome initial unfamiliarity. He notes that the Sherman's reliability allows his battalion to maintain higher operational readiness than comparable T units, and that the superior vision blocks significantly reduced casualties by allowing crews to spot threats earlier. Soviet employment of Shermans differs from American doctrine, with Soviet forces using Shermans primarily for exploitation and pursuit rather than assault, but the tanks prove effective in this role. The fact that the most experienced tank army in the world, operating on the most intensive tank combat front of the war, finds the Sherman superior to their own well-regarded design validates American design choices. November 1944, the German border. The weather turns cold, then freezing. Rain becomes sleet, then snow. American armored divisions continue operations despite conditions that would halt less mechanically reliable forces. The Sherman's automotive-based design, derided by purists who prefer purpose-built military components, proves its worth. Crews can start frozen engines using techniques familiar to any American who has operated an automobile in winter conditions. Maintenance procedures, straightforward and well-documented, can be performed by crew members without requiring specialized tools or training. The wide tracks of the HVSS-equipped Shermans distribute weight effectively, allowing movement through snow and mud that would immobilize narrow-tracked vehicles. German Panthers and Tigers, with their complex suspension systems and narrow tracks relative to their weight, frequently become stuck in winter conditions. Recovery becomes difficult or impossible when recovery vehicles themselves cannot move through the terrain. American armored operations continue throughout the winter of 1944-1945, maintaining pressure on German forces and preventing them from consolidating defensive positions. The Rhine crossing operations in March 1945 demonstrate the Sherman's utility in river crossing operations. The M4 can be waterproof to allow wading through water up to the hull top, enabling it to cross rivers using ford sights or improvised bridges. The DD variant, despite its mixed record on D-Day, proves effective in crossing the Rhine at several points, providing immediate armored support on the eastern bank before permanent bridges are constructed. Engineers develop specialized Sherman variants for obstacle crossing, including the M4 dozer tank with bulldozer blade, the M4A3E2 jumbo, assault tank with extra armor for leading attacks on fortified positions, and various mine-clearing variants. This adaptability, the ability to modify the basic Sherman design for specialized tasks without requiring entirely new vehicle development, accelerates American operations by ensuring that the right equipment is available when needed. April 1945, Germany. American armored divisions drive deep into German territory, encountering decreasing resistance as German forces collapse under the weight of simultaneous offensives from east and west. Sherman-equipped units race across Germany, liberating concentration camps, capturing NG cities, and linking up with Soviet forces at the Elbe River. The campaign demonstrates everything that makes the Sherman an effective weapon system: reliability that enables sustained operations, numbers that allow rapid replacement of losses, crew survivability that preserves experienced personnel, combined arms coordination that overcomes tactical challenges, and industrial backing that ensures continuous supply of ammunition, fuel, and spare parts. German Panzer forces, reduced to scattered units hiding from air attack and unable to maneuver due to fuel shortages, can offer only sporadic resistance. The few remaining Tigers and Panthers, technically superior to any Sherman on a specification sheet, sit abandoned beside roads, out of fuel or broken down, monuments to a losing strategy. The final accounting tells the story with merciless arithmetic. Germany produced 1,347 Tiger I tanks, each capable of destroying any Allied tank at ranges exceeding 2,000 meters, each representing the pinnacle of German engineering and approximately 300,000 man-hours of labor. The United States produced 49,234 Sherman tanks, each mechanically reliable, each representing approximately 7,500 man-hours of labor, each part of an integrated military system that included training, logistics, tactical doctrine, air support, artillery coordination, and industrial replacement capacity. Germany destroyed thousands of Shermans in combat. The United States replaced them faster than Germany could destroy them, while simultaneously destroying, capturing, or forcing the abandonment of virtually every German tank produced. By May 1945, German armored forces effectively ceased to exist. American, British, and Soviet armored forces occupied Germany, their Shermans, Churchills, Cromwells, and T-34s rolling through German cities, while German Tigers and Panthers rust in fields or sit in factory yards, never completed due to lack of materials. The myth of the Sherman as a death trap, as an inferior tank that won only through overwhelming numbers, persists in popular imagination despite contradicting the historical evidence. This myth originates partly from wartime accounts by men like Belton Cooper, a maintenance officer who saw the worst results of tank combat without seeing the broader strategic picture. Cooper's book Death Traps, published decades after the war, popularizes the idea that American tank crews fought in equipment they knew to be inferior, suffering unnecessarily because American military leadership refused to develop better tanks. This narrative, emotionally compelling and dramatic, contains elements of truth but misses the fundamental point. Sherman crews did face German tanks with superior armor and guns. American tankers did die in significant numbers, did see their tanks burn, did fear facing Tigers and Panthers. But they also won the war. They won every major campaign. They drove German forces from Africa, Italy, France, and finally Germany itself. They did this not despite the Sherman but because of it. The Sherman succeeded because American military leadership understood modern warfare in ways that German leadership did not. War is not decided by individual tank versus tank engagements. War is decided by the ability to put effective combat power on the battlefield consistently, continuously, and in sufficient quantity to accomplish strategic objectives. The Sherman, with its 96% mechanical availability rate, its rapid production time, its crew survivability, and its adaptability to various roles and conditions, provided this capability. German Tigers and Panthers, magnificent engineering achievements that could dominate any individual battle, could not achieve strategic victory because there were never enough of them. They broke down too frequently. They consumed resources out of proportion to their contribution, and their crews could not be replaced when killed. Germany's armored forces represented an unsustainable strategy, brilliant tactically but flawed strategically. The final irony is that the Sherman's supposed weaknesses were largely addressed during the war through systematic improvement. Early Shermans burn easily. Wet stowage reduces burn rates to levels comparable with or better than other tanks. Early Shermans cannot penetrate Panther and Tiger frontal armor. The 76mm gun and the Firefly provide adequate anti-armor capability. The original suspension proves adequate for most conditions, but the HVSS provides improved performance when needed. American forces identify problems, develop solutions, implement them, and move forward. German forces, increasingly unable to modify existing designs or implement new ones due to resource constraints and bombing disruption, fight with equipment whose shortcomings cannot be addressed. The Panther's engine fires, the Tiger's transmission failures, the logistical burden of maintaining multiple incompatible tank types. These problems persist because Germany lacks the industrial capacity and time to solve them, while simultaneously replacing combat losses. Lafayette Pool, the Texas tanker who stands in his Sherman turret that foggy morning near Arracourt, embodies the American approach to armored warfare. He is not the most technically skilled tank commander in the war. That distinction probably belongs to some German or Soviet ace whose name never becomes widely known. He does not command the most powerful tank. That distinction belongs to the German crews in Tigers and King Tigers, assuming their vehicles are running. What Pool represents is systematic competence multiplied by industrial capacity. He is trained thoroughly in a system that processes thousands of tankers through progressive training programs. He commands a reliable tank produced by an industrial system that can replace any losses. He fights as part of combined arms teams that coordinate armor with infantry, artillery, engineers, and air support. He benefits from an intelligence system that provides accurate information about enemy dispositions and capabilities. He operates in a military culture that values innovation and adapts quickly to changing circumstances. When he is wounded, he is treated in a medical system that saves his life and returns him to service in a training role. His knowledge is not lost when he leaves combat. It is spread to hundreds of new tankers who will apply his lessons in their own combat operations. The German tankers who face Pool and his comrades represent a different approach. They are often superbly trained, their equipment is technically superior, and their tactical doctrine is sophisticated. But they fight as part of a military system that is being systematically destroyed by strategic bombing, resource shortages, and unsustainable attrition. When a German tank ace dies, his expertise dies with him. When a Panther is destroyed, replacing it takes months and diverts resources from other critical needs. When a Panzer division is defeated, reconstituting it requires time, equipment, and trained personnel that Germany increasingly cannot provide. The German approach to armored warfare, focused on technical perfection and individual excellence, cannot compete with the American approach of mass production, systematic training, and combined arms integration. September 19, 1944, late afternoon. The fog has burned off, replaced by clear autumn sky that allows American P-47s to fly continuous missions over the battlefield. Lafayette Pool sits in an aid station, medics treating the leg wound that will end his combat career. His Sherman, in the mood, sits abandoned on the battlefield, its engine damaged by a German shell that penetrated the rear deck. By tomorrow, recovery crews will tow it back to a maintenance depot. Within a week, it will return to combat with a replacement crew. Pool's gunner, Corporal Willis Aller, has already been reassigned to another Sherman in the company. The loader, driver, and bow gunner continue fighting in their new tank. The crew's expertise does not die with Pool's wound. It disperses through the unit, raising the overall competence level of the entire battalion. This is American armored warfare in microcosm: systematic, sustainable, relentless. Hauptmann Franz Beck sits in his command post that same evening, reviewing casualty reports that make grim reading. His brigade has lost 43 tanks today, destroyed or damaged beyond immediate repair. 16 crews are dead, 32 wounded, 11 missing. Replacement tanks will not arrive for weeks, if at all. Replacement crews cannot be trained quickly enough to matter. His Panthers, magnificent machines when they function, have mechanical availability rates hovering around 60%. At any given moment, 40% of his armor sits immobile, waiting for parts or repairs. American fighter bombers control the sky, making movement during daylight hours suicidal. American artillery can strike any position within 15 minutes of being called. American infantry coordinates seamlessly with their armor, making it impossible to exploit the inevitable gaps in tank formations. Beck realizes, with the clarity that comes from watching carefully laid plans disintegrate under contact with reality, that he is not fighting American tanks. He is fighting American industrial capacity, American logistics, American doctrine, and American will. Individual German technical superiority means nothing against this system. The battle is lost. The campaign is lost. Perhaps the war itself is lost. March 6, 1945, outside Cologne, Germany. Sergeant Robert Early commands a Sherman from the 3rd Armored Division, part of the force fighting to capture Germany's 4th largest city. His tank, nicknamed Eagle, has been in continuous service since D-Day +7, when it landed at Normandy. The tank has received 4 different engines during its service life, each replaced during routine maintenance raids. Than after failure, it has gone through 7 sets of tracks, 2 transmissions, 3 final drives, and countless smaller components. The hull shows battle damage from multiple engagements, a gouge across the glacis from a Panther round that struck at an extreme angle and deflected, a patch-welded repair on the left sponson, where a Panzer penetrated but failed to ignite ammunition due to wet stowage, and dozens of small arms impacts that scarred the armor without penetrating. Early is the tank's 3rd commander. The first was killed in the Bocage fighting, the second transferred to a training unit after being wounded at the Siegfried Line. Early himself has been with the tank for 3 months, long enough to know its quirks and trust its reliability. The fighting in Cologne demonstrates every lesson learned over 3 years of combat. American forces do not assault blindly into the city. Instead, artillery and airstrikes systematically destroy German defensive positions. Infantry scouts identify strongpoints and bypasses. Engineers clear obstacles and bridge gaps. Tank infantry teams advance in coordinated bounds, each element covering the other. When German armor appears, usually individual tanks positioned in rubble to serve as immobile pillboxes, American forces call in tank destroyers or use Shermans to suppress the position, while engineers maneuver to attack with demolition charges. The tactics are methodical, almost industrial in their systematic application. American forces trade time and ammunition for reduced casualties, a luxury that only forces with abundant supplies can afford. German defenders, lacking ammunition for sustained fire and unable to maneuver due to fuel shortages, can delay but not stop the American advance. The city falls after 5 days of fighting. The famous footage of a Sherman destroyed in Cologne streets, its crew escaping under fire while being filmed by a cameraman, provides a final testament to Sherman's survivability. The tank, struck by a Panther firing from a concealed position, erupts in flames as ammunition ignites. The crew immediately begins evacuation. The driver and bow gunner exit through their overhead hatches, dropping to the street and running for cover. The turret crew emerges from the commander's cupola, flames licking around them, and jumps from the tank. All 5 crewmen survive, though several suffer burns and injuries. Within hours, they receive medical treatment. Within days, the wounded go to hospital facilities while the uninjured join another crew. The Panther that destroyed their Sherman is itself destroyed minutes later when Sergeant Clarence Smoyer's Pershing tank engages it from a flanking position, demonstrating the combined arms principle. No tank fights alone. Every loss invites immediate retaliation from supporting units. April 12, 1945, President Franklin D. Roosevelt dies. The man who signed executive orders authorizing tank production programs, who approved Lend-Lease shipments to Britain and the Soviet Union, who directed American industrial mobilization, dies without seeing the final victory he made inevitable. By the time of his death, American factories have produced 49,234 Sherman tanks, a number so large it defies easy comprehension. If these tanks were lined up bumper to bumper, they would stretch for 190 miles. If production hours were calculated, they represent approximately 370 million man-hours of labor, equivalent to 42,000 people working full-time for 10 years. The economic cost exceeds $6 billion in 1945 dollars, approximately $95 billion in 2025 dollars. This expenditure, vast as it is, represents only the tank production itself, not including ammunition, spare parts, training facilities, or operational costs. The Sherman program, viewed as an economic undertaking, ranks among the largest single military equipment programs in human history, exceeded only by programs like the B-29 bomber and the Manhattan Project. The question that historians debate endlessly centers on whether this expenditure was necessary, or whether America should have developed heavier tanks with more powerful guns earlier in the war. Could American forces have achieved victory with fewer casualties if they had fielded tanks equivalent to Panthers and Tigers? The question, superficially reasonable, misses crucial factors. First, developing and producing a heavier tank would have delayed American entry into armored combat. The Sherman design, evolutionary rather than revolutionary, allowed rapid production because it used proven technologies and existing manufacturing capabilities. A completely new design would have required additional development time, new production facilities, and training for both manufacturers and crews. Second, heavier tanks would have complicated logistics. The Sherman's weight and dimensions allowed it to be transported using existing ships, rail cars, and bridging equipment. Heavier tanks would have required specialized transport and engineering equipment that did not exist in 1940–43. Third, heavier tanks would have reduced production numbers. If American factories produced, hypothetically, 25,000 heavy tanks instead of 50,000 Shermans, would this have improved military effectiveness? Evidence suggests not. The Sherman's numerical advantage, combined with air superiority and artillery support, proved more effective than fewer, more powerful tanks would have been. The Pacific Theater provides perhaps the clearest evidence of Sherman effectiveness, because Japanese armor posed minimal threat, allowing the Sherman to perform its designed role without facing the superior German tanks that complicated European operations. Japanese tank design lagged significantly behind Western and Soviet standards. The Type 97 Kaiha, Japan's most numerous medium tank, mounted a 47 gun that could barely penetrate Sherman armor at any range, while its own armor, maximum 33, could be penetrated by every American tank weapon. The Type 95 Hago light tank, even more numerous, was effectively a mobile pillbox rather than a combat vehicle capable of fighting other tanks. Sherman crews in the Pacific rarely engaged in tank versus tank combat. Instead, they provided mobile fire support for infantry assaulting fortified positions. The 75 high-explosive round, relatively ineffective against German heavy armor, proved devastating against Japanese bunkers, pillboxes, and cave positions. The armor, vulnerable to German 88 guns, provided complete protection against Japanese small arms, machine guns, and light anti-tank weapons. The reliability, questionable in comparison to simpler armored vehicles, proved essential in tropical conditions where heat, humidity, and lack of roads destroyed less robust equipment. The Battle of Tarawa, November 1943, saw the first use of Shermans in Marine Corps amphibious assaults. The 2nd Tank Battalion's M4A2 Shermans waded ashore through shallow water, their waterproofing allowing them to operate in conditions that would disable most armored vehicles. Japanese defenders, equipped with 37 and 47 anti-tank guns, scored multiple hits but rarely achieved penetrations. The Shermans systematically destroyed Japanese fortifications, their armor allowing them to approach positions that infantry alone could not assault. Crew testimonies describe Japanese soldiers attempting to stop Shermans by placing magnetic mines or explosives against the hull, requiring accompanying infantry to protect the tanks from close-range attack. This infantry-tank coordination, practiced and refined through successive campaigns, became standard Marine Corps doctrine. At Iwo Jima, Okinawa, and throughout the Philippines, Shermans provided the mobile firepower that allowed American forces to reduce Japanese defensive positions at acceptable cost. The tank's role shifted from tank killer to bunker buster, demonstrating the adaptability that made the Sherman valuable across every theater of war. First Lieutenant Robert Neiman commands a Sherman from the 710th Tank Battalion during the Philippine Campaign. His crew fights through mountainous jungle terrain where roads barely exist and visibility rarely exceeds 50 yards. The Sherman proves surprisingly capable in this environment. Its ground pressure, relatively low due to wide tracks, allows movement through soft ground that defeats heavier vehicles. Its compact size permits navigation through jungle trails that would block larger tanks. Most importantly, its reliability means the tank remains operational despite conditions that destroy electrical systems, clog air filters, and overheat engines. Neiman's crew develops techniques for close-range combat, using the .50 caliber machine gun mounted on the commander's cupola to clear vegetation and suppress Japanese positions, then firing high-explosive rounds at point-blank range into bunkers and cave entrances. The fighting is exhausting, terrifying, and effective. Japanese positions that would require days to reduce using infantry and artillery alone fall in hours when Shermans provide direct fire support. The crew survives the campaign, their Sherman requiring only routine maintenance despite months of combat in the worst possible conditions. The statistical summary of Sherman combat performance tells a story that individual battle accounts sometimes obscure. In Northwest Europe from D-Day through VE Day, American armored divisions suffered approximately 1,600 Sherman losses to all causes. German forces suffered total armored vehicle losses exceeding 7,000 vehicles in the same theater and period. The exchange ratio, despite German technical superiority in individual tank versus tank engagements, favored American forces by more than 4-1. Soviet forces operating on the Eastern Front, facing the majority of German armor, destroyed an estimated 20,000 German armored vehicles during the same period, though Soviet losses exceeded 40,000 tanks, including both T-34s and Lend-Lease Shermans. The overall picture shows that while German tanks dominated individual engagements, they could not achieve strategic success against opponents with superior numbers, logistics, and combined arms doctrine. The Germans won battles. The Allies won the war. Crew survival statistics provide additional perspective on the death trap myth. Studies of American tank crew casualties in Northwest Europe show that approximately 18% of tank crewmen became casualties during the campaign, including killed, wounded, and missing. This casualty rate, while significant, compares favorably to infantry casualty rates approaching 30% for rifle company personnel and 40% for rifle platoon leaders. Tank crewmen faced danger, certainly, but they remained safer than infantrymen advancing on foot. More importantly, the survival rate for crew members in tanks hit and knocked out reached approximately 50%, meaning that even when their tank was destroyed, half the crew survived to fight again. German tank crew survival rates, though difficult to determine precisely due to incomplete records, appear significantly lower, particularly in the war's final year when experienced crews could not escape deteriorating tactical situations. Soviet tank crew survival rates were notably lower still, with estimates suggesting that fewer than 30% of crewmen survived their tank being knocked out, due partly to inadequate crew escape provisions in T-34 designs. The economic dimension of the Sherman success extends beyond mere production numbers to encompass the entire industrial system that supported it. American factories produced not just tanks but the complete ecosystem of parts, ammunition, fuel, and support equipment necessary for sustained operations. The Army established supply depots throughout Europe and the Pacific, each stocked with thousands of common components. A Sherman with a damaged engine could receive a complete replacement power pack, installed in hours, with the damaged engine returned to a rear area facility for repair and returned to the supply system. This circular logistics, wasteful by peacetime standards, proved incredibly effective in wartime. German forces, increasingly unable to maintain their logistical networks under Allied bombing and ground advances, could not match this support system. Panthers and Tigers abandoned due to repairable damage littered every battlefield, monuments to a logistics system that could not sustain Germany's high-performance armor. May 7, 1945, Germany surrenders unconditionally. German armored forces, once the most powerful in the world, ceased to exist as organized formations. The surviving Tigers, Panthers, and other German tanks sit abandoned, captured, or hidden by units that dissolved rather than surrendered. American, British, and Soviet armored forces occupy Germany, their tanks parked in German cities as symbols of total military defeat. The Sherman, derided at the war's beginning as inferior to German designs, remains in service with armies worldwide. American armored divisions prepare for redeployment to the Pacific, where planning staffs estimate that the invasion of Japan will require every available Sherman. The atomic bombing of Hiroshima and Nagasaki makes this invasion unnecessary, but the planning reveals American confidence that Sherman-equipped forces could successfully invade and conquer the Japanese home islands despite expected fanatical resistance. The Sherman's post-war career validates its design philosophy. American forces retained Shermans in service through the Korean War, where they faced Soviet-designed T-34-85 tanks operated by North Korean forces. In these engagements, Sherman 76 and Firefly variants prove capable of defeating T-34s, with encounter battles generally favoring the side with better crew training and tactical position rather than superior equipment. Israeli forces operate Shermans successfully through multiple Arab-Israeli conflicts, upgrading them with French 75 mm and British 105 mm guns to maintain effectiveness against more modern Soviet armor. French forces operate Shermans in Indochina and Algeria. Pakistani and Indian armies operate Shermans into the 1960s. The basic design's adaptability allows continuous upgrades, extending Sherman service lives decades beyond World War II. This longevity, this usefulness across changing tactical environments and against different opponents, demonstrates that the Sherman was not merely good enough, but actually well designed for modern mechanized warfare. German testimony about the Sherman provides the final perspective on its effectiveness. Otto Carius, writing years after the war, acknowledges that while German tanks held technical advantages, the Americans understood war as an industrial process, and they executed this understanding brilliantly. We could destroy 5 of their tanks, and 10 more would appear. We killed their crews, and replacement crews arrived the next day. We fought as craftsmen, each tank a masterpiece. They fought as manufacturers, each tank a unit of production. In retrospect, their approach proved correct. This admission from a man who fought Sherman-equipped forces repeatedly and survived through exceptional skill and considerable luck captures the essential truth. The Sherman won not despite being mass-produced, but because it was mass-produced. The decision to build 50,000 reliable, adaptable, sustainable tanks rather than 10,000 superior tanks determined the war's outcome more certainly than any individual battle. Hauptmann Heinrich Schulz, commander of a Tiger company in Normandy, writes in his diary about engaging American forces. Each time we destroy their Shermans, more arrive. We calculated today that my company has destroyed 43 American tanks since D-Day. Yet the Americans have more tanks in Normandy now than they did on June 6th. We have lost 6 Tigers in the same period. We cannot receive replacements. Our supply officer informed us this morning that replacement Tigers are assigned to the Eastern Front. We will fight with what we have until we have nothing, and then we will fight as infantry. The Americans will still have their Shermans. Oberst Kurt Meyer, evaluating American armored tactics after being captured, provides analysis that demonstrates German understanding of their situation. The Americans never gave us the battle we wanted. We sought to engage their tanks at maximum range, where our superior guns and armor meant victory. They refused. They used terrain, smoke, artillery, and air support to close the range, then overwhelmed us with numbers. When we destroyed their forward tanks, others attacked our flanks. When we defended against flanking attacks, aircraft struck us from above. We could win every individual engagement and still lose the battle, lose the campaign, lose the war. Their Sherman tank was adequate for their strategy. Our Tigers and Panthers were magnificent weapons unsuited to our strategic situation. The transformation of perception about the Sherman, from death trap to war winner, occurs gradually in historical analysis as documents become available and veterans share their experiences. The immediate post-war narrative, influenced by accounts like Belton Cooper's Maintenance Perspective and by natural focus on dramatic tank versus tank duels, emphasizes German technical superiority and American losses. Later analysis, incorporating broader operational and strategic perspectives, recognizes that wars are won by logistics, production, training, doctrine, and national, well, at least as much as by individual weapon systems. The Sherman embodied these factors. It was reliable enough to maintain high operational availability rates. It was producible in quantities sufficient to replace losses and equip expanding forces. It was survivable enough to preserve crew experience. It was adaptable enough to incorporate improved weapons and equipment. It was logistically supportable across global supply lines. Most importantly, it was part of an integrated military system that used combined arms coordination to overcome tactical challenges. The final accounting reveals numbers that define the war. 49,234 Shermans produced, 1,347 Tiger I tanks produced. American tank crew casualty rate approximately 18%. German tank crew casualty rate estimated above 30%. Sherman mechanical availability rate 96%. Tiger mechanical availability rate approximately 60%. American tank production during peak months exceeding 2,000 units. German tank production during peak months approximately 600 units of all types combined. These numbers, dry and statistical in isolation, represent human decisions about how to wage industrial warfare. The Americans chose quantity, reliability, and sustainability. The Germans chose quality, power, and technical sophistication. History records which choice proved correct. Lafayette Pool's Sherman, recovered from the Arracourt battlefield, receives repairs and returns to service. The crew that takes it into subsequent battles never knows that it carried one of America's most successful tank commanders during 81 days of combat. The tank is simply another Sherman, another unit of production in an army of 50,000 identical tanks. This anonymity, this interchangeability, represents the ultimate vindication of American design philosophy. Heroes matter, certainly. Skill matters. Training and tactics and leadership all matter. But systems matter more. Industrial capacity matters more. The ability to replace losses matters more. The Sherman, mocked as a Ronson lighter, derided as a Tommy Cooker, dismissed as inferior by every German tanker who faced it, won the war because it was exactly what a modern industrial military needed. A tank that was good enough, reliable enough, producible in sufficient quantity, and supported by a military system that understood victory comes from sustainable superiority rather than individual excellence. The crews who fought in Shermans, who climbed into these 33-ton steel boxes day after day knowing that superior German armor waited in ambush, who watched friends burn and die, who felt shells clang off armor and prayed the next one would not penetrate, these men won the war. They won not because their tank was better than German tanks in individual combat. They won because they were part of a military system that was better than the German military system. They won because American factories could produce 5 Shermans for every German tank. They won because American logistics could keep those Shermans supplied with fuel and ammunition. They won because American training replaced lost crews with competent replacements. They won because American doctrine used combined arms to overcome German tactical advantages. They won because America understood that modern war is industrial, systematic, and ultimately won by the side that can sustain operations longest. From the deserts of North Africa to the bocage of Normandy, from the streets of Cologne to the jungles of Luzon, the Sherman proved itself not as the best tank of World War II, but as the right tank for America's way of war. It rolled off production lines at a rate that Germany could not match. It rumbled across battlefields on tracks that rarely broke. It survived penetrating hits that would have killed German crews, protecting American tankers who lived to fight again. It adapted to new weapons, new tactics, and new battlefields with a versatility that purpose-built systems could not achieve. It won the war not despite being a mass-produced, good-enough design, but precisely because it was mass-produced and good enough. The Tiger and Panther may have been better tanks. The Sherman was the better weapon system. And in the end, that distinction made all the difference between victory and defeat, between freedom and tyranny, between a world dominated by fascism and a world where democracy survived to flourish. Every Sherman that rolled off American production lines carried that future forward, 33 tons at a time, reliable and unstoppable, toward inevitable victory.